Welcome to part 2 of the Fundamental Theorem of Calculus. In this video, we're going to use the mean value theorem and the average value theorem. We're going to use the second fundamental theorem of calculus to determine the area under a curve. And so let's get started. All right, so we had a mean value theorem for differentiation. And it talked a lot about a function that was continuous on a closed interval, and that there had to be a value between in that interval from A to B that was the average or the mean value between that. Now for integrals, remember that you're talking about an integral as being the area under a curve. And so what that says is that the area under the curve from A to B, this is f of x, so that would be this measure right here, that somewhere in here there's a value c, where if you drew this rectangle here, that would be the same area. So what that says is you would have f of c, that's the height, right? That's the height of your rectangle. And then b minus a would be the length of the rectangle. So this is the area of this rectangle that's drawn through C, and that is going to be equal to the area under the curve. And so that is your mean value theorem. Now, the interesting part about this is if I divide both sides by b minus a, then I end up with 1 over b minus a from a to b of f of x dx equals f of c. So this is the value, this is the formula, it's the same thing as the average value theorem. And we're going to use that to solve for and define c. Okay, so find c guaranteed by the mean value theorem. So we are going to use the mean value theorem, but written in the form of the average value. What we're adding, however, is that it has to be equal to f of c. All right, so let's do f of c first. So let's just say, all right, f of c is going to be, in this case, c squared plus 4c plus 1. Okay, we know that a is 0 and b is 2. And then our f of x is this function that's written here. So over here I've written that f of c and some of the given information. Now over here I'm going to do this side. So I have 1 over b minus a, which is 1 over 2, from 0 to 2, of x squared plus 4x plus 1 dx. I'm going to integrate and take the definite integral. So to integrate, I've got 1/2 times x to the third over 3 plus 4x squared over 2 plus x from 0 to 2. Okay, so I have 1/2. When I put a 2 in here, I get 8/3. This is 2 times 4, which is 8, plus 2, and then that would just be minus 0, because if you put a 0 in for x on all those, you're going to get minus 0. So that's the definite integral. So this is 10/3, or 10, which is 30/3, so this is 1/2 times 38/3, and the 2 and the 38 are going to cancel to 19. So what I end up with is I end up on this side with 19/3. All right, so 19/3 is going to equal f of c. Well, we've already figured out what f of c is. So 19/3 is equal to c squared plus 4c plus 1. When you subtract that to the other side to get a quadratic equation, you get something that's kind of not easy to deal with without using either the quadratic formula. What I did is I put this in my calculator and found the zeros. And one of the zeros that I found for c that was in the interval from 0 to 2, don't forget your interval, was 1.0, I think that's right, 1.055. And it goes on from there, but I'm going to round it to 3 digits. And so that's the value of C that provides the average value and is guaranteed by the mean value theorem. Okay, so on this next example, we're going to revisit the particular solution. We're given the derivative of a function. Here's the derivative of a function with an initial condition, and then we want to find this additional condition, y of 3. All right, so we need the function y. So the first thing we're going to do is we're going to integrate, and then we're going to use the initial condition to find c, and write the particular solution, and then use that particular solution to find y of 3. So this is pretty much the way we've learned before. So we have here, when you integrate dy dx, right? Because if you think about it, if you have dy dx and you integrate it, move the dx over here, y equals this. So let's go ahead and integrate. I've said that long enough, I think. 3x to the third over 3 plus 4x squared over 2 minus 5x, okay, plus c. All right, so we have x to the third plus 2x squared minus 5x plus c. And what they told us here, that equals y. Okay, y of x. And so it told us that our initial condition, where x is 2, y of 2 was negative 1. So I'm going to substitute the negative 1 here. This is 2 to the third plus 2 basically to the third. That's 5 times 2 plus c. So I have 8. This is 8. Plus 8 is 16. Minus 10 is 6, so I have 6 plus c equals negative 1, so c is going to equal negative 7. Okay, so I end up with x to the third plus 2x squared minus 5x minus 7 equals y. And now they want us to find y of 3. So I do that. I do 3 to the third plus 2 times 3 squared minus 5 times 3 minus 7 equals y 3. So this is 27 plus 918 minus 15 minus 7. So I've got 22, so that's 5. So that is 23. All right, so that is equal to y of 3. Okay, we are going to work the same problem, only this time using method 2, which is to use the fundamental theorem of calculus, which shows right here the definite integral, right? And we're going to rearrange this just a bit based on the information that they've given us. So we need to interpret this formula in light of the given information, all right? So the first thing is we know that this is the derivative, right? F prime of x is the derivative, dy dx is the derivative, so I know that that is what's going to go in here. Now we need to think, what is a and what is b? Well, a and b are always used as an interval, right? On the x-axis from a to b. So if I look here, the x values are 2 and 3. So in this case, a will be 2 and b will be 3. The other thing that we know is that we know what f of 2 is. F of 2 is negative 1, and we're being asked to find f of 3. So that's our unknown. So what we want to do first is we want to rearrange this a little bit so that we have f of b on one side and everything else on the other. So I'm going to have f of b is equal to f of a plus a to b of f prime of x dx. And then we want to fill this in. So f of 3 is equal to f of 2 plus the integral from 2 to 3 of 3x squared plus 4x minus 5 dx. Okay, so I know what f of 2 is because that's given. So that is negative 1 plus, and then once again we find the derivative, so that, or the integral, so that's going to be x to the third from the last page plus 2x squared minus 5x from 2 to 3. All right, so that gives me -1 plus, and then I have 27 plus 18 minus 15, and then minus 8 plus 8 minus 10, so that is 6, and this is 30. So 30 minus 6 is 24. -1 plus 24 is, boom chakalaka, it's 23. So you get the same thing using the fundamental theorem of calculus as we did before using the definite, finding the integral and then solving for c. So that's our second method to find a particular solution. So sometimes there's no antiderivative for what we want to do, and so we have to use method 2 and our graphing calculator to solve. All right, so we have that f prime of x is sine of x squared, and f of 2 equals -5, and so we want to find f of 1. Okay, so we're going to start off with the fundamental theorem of calculus, which is from a to b of f prime of x dx equals f of b minus f of a. All right, and once again we know what the derivative is, so we also know a and b. So we have a is for 2, or sorry, a is 1, b is 2. We know that f prime is sine x squared dx, and that's going to equal f of b. F of b is 2 minus f of 1. Okay, so we know that f of 2 is -5, and then we don't really know what this is, because there's no way to use substitution to find it. There's no way to use integration to find it. So we have to put that in our calculator. And so what you want to do is go to your math, and you want to look for the integration, which I think is 8, and then put that in your calculator to solve it. So we want to solve for f of 1. So what I'm going to do is kind of rearrange things, right? So I want to move this. I want to move this over here and this over here. So f of 1 is equal to -5. This f of 2, right? And then minus what I find for this value using my calculator. No other way to do it. Have to put it in your calculator. So that's going to turn out to be -5 minus, and I'll show you this again in class since this is really hard to see on here, but you should get, if you do it right, 0.4945, which will get -5.495. Now, this is the method that you have to use if there's no antiderivative, if you can't take the integral, because there's no way to integrate. Then you need to have the fundamental theorem of calculus to be able to determine what that value is. All right, so in this last example, we're going to use geometry. So you'll remember that the definite integral from a to b of a function is really just describing the area between the curve and the x-axis. So we're given the graph of f prime. So not a function, we're just given a graph. This is a piecewise function, but it is 2 lines in a semicircle. So knowing that this is the x-axis, we can find the area of the triangle, the area of the semicircle, and that is the definite integral from a to b. So we know what this part of the fundamental theorem is. We also have been given the initial condition. We know that the f of a, this is going to be a, is going to be equal to 5. So in everywhere that we use this, we know that f of a is 5. And then what we're asked to find is f of b. All right, so let's do a. we have, we know we're going to rearrange this a little bit because we want f of b to be on one side and we want f of a to be on the other. So we're going to have this is f of b, right here. So f of 0 is going to be equal to f of negative 2, which is 5, plus the definite integral from negative 2 to 0 of f prime of x dx. Well, this part right here is just the area under the curve from 0 to, or from negative 2 to 0. So if we start counting here, the area of this is 2 times 4 divided by 2, which is 4. So this part is 4. F of negative 2 is 5. And so f of 0 is going to be 9. Right? So if we do from negative 2 to 2, we know that f of 2 is going to be equal to 5 plus the area under the curve from negative 2 to 2. So 1, 2, 3, 4, 1, 2, 3, 4. 4 times 4 is 16, divided by 2 is 8. F of 2 is going to be equal to 13. Now, on the last one, we're going from negative 2 to 6. And so, once again, f of 6 is equal to 5. 5 is f of a, right? F of negative 2, plus the integral, right? So that would be the area from negative 2 to 2, which is 8, plus the semicircle, which is below the x-axis, so that's going to be negative, and the area of that is 4 pi divided by 2, so that's going to be negative 2 pi. So this is going to be, instead of plus, it's going to be minus 2 pi. Now, what I would like for you to do is, well, finish the problem, of course. What I would like for you to do is to go back and look again at these problems and see if you can make the connection between the definite integral and the area under the curve, because that's what we're trying to find. All right, and then I will see you in class.